Recording started.
Okay, in this episode, we are going to be talking a little bit about polar equations. So let's talk about some basics now. In the polar coordinate system, instead of having an x, y, we have an r, which is a radius, and a theta, which is an angle. So that means my r is how far out along the axis I go, and my theta is the angle that I move through. So when you talk about a point, instead of saying how far left or right and then how far up or down, you're going to say how far over and then what angle do you rotate that point through. Is theta. Okay. Polar equations for the relationships that you need to know to convert from polar to rectangular coordinates are these. That x is r times the cosine of theta, y is r times the sine of theta. You can get r squared by taking x squared plus y squared, and the tangent is always going to be y over x. So let's talk about an example. Here is my first example. In my first example, I want to convert this point, which is in polar coordinates, and I know it's in polar coordinates because, of course, it has the degree sign. I want to convert that into rectangular coordinates. Well, okay. We need an x and a y. So let's start out with the x. So I know that x has to be equal to r times the cosine of theta. Well, r is 5, so it's going to be 5 times the cosine of 180 degrees. Cosine of 180 degrees, though, is just a 1, so this is going to be 5 times 1, which is just a 5. So there's my x. Y is going to be r times the sine of theta. So it's going to be 5 times the sine of 180 degrees. Sine of 180 degrees is a 0. So I have 5 times 0, and I get 0. So my xy point will be 5, 0. So that's the same as the 5, 180 degrees in polar coordinates. Let's do another one. This time I'd like to convert rectangular coordinates, and this is 1, square root of 3. I'd like to convert that into polar coordinates. Well, the first thing I need to know, well, I need to know two things. I need to know r and theta. But I have to know that r squared is equal to, well, it's equal to x squared plus y squared. Well, okay, that's going to be 1 squared plus the square root of 3 squared. So that's going to be 4. So if r squared is equal to a 4, let's take the square root of both sides and get r is equal to a 2. Okay, I found r. Now I need to find the angle. Well, the easiest way to find the angle is to remember that the tangent is equal to y over x. So the tangent is equal to the square root of 3 over 1. So tan theta is equal to the square root of 3 over 1. So theta will be equal to the tangent inverse of the square root of 3 over 1, or just the square root of 3. And if you take the tan inverse on your calculator or look on the unit circle, you will see that that's going to be at 60 degrees. So let's write out the point. Our point in polar coordinates would be an r of 2 and a theta of 60 degrees. That's going to be our polar coordinate point. So we can now convert back and forth from rectangular to polar and from polar back to rectangular. So let's talk about converting some polar equations. Now in the homework you did a bunch of polar equations. You graphed them and you looked at them and identified which one was a lemniscate and that kind of thing. But let's just convert a polar equation into a rectangular equation. So here I have r equals 3 times the cosecant of theta. I'm going to rewrite that a little bit. I'm going to say r equals 3 times 1 over the sine of theta. I'm going to say, really, 3 over the sine of theta. Okay? So I have r equals 3 over the sine theta. How about I do this? How about I multiply both sides by the sine of theta? So I'm going to multiply the left side by the sine theta and the right side by the sine of theta. And of course, these guys are going to cancel over here on the left-hand side. So I'll have r times the sine of theta is equal to a 3. Well, if you remember, y was equal to r sine theta. So I'm just going to substitute this right back in. Instead of saying r sine theta, I'm going to say y equals 3. And there you go. I've just converted that polar equation into a rectangular equation. All right, let's try a little bit harder. So here we go. We have r equals 2 over 4 cosine theta minus 3 sine theta. How about I do this? How about I do a little cross multiplying? I'm going to say that this is the same as r over 1. I'm going to just do some cross multiplying. I'm going to multiply 1 times 2, and I'm going to multiply r times 4 cosine theta. So I'll wind up with, after I cross multiply, 4 times r cosine theta minus 3 times r sine theta equals a 2. But again, we can substitute, because remember, r cosine theta, that's just an x. R sine theta, that's just a y. So I come down here, and after the substitution, I can say that's really 4x minus 3y equals a 2. And there you go. I've got it in rectangular format. So I've just rewritten that polar equation into a rectangular form. You'll have to do a bunch of that in the homework.